Hello everyone, welcome to Big Data 101, a video series where we explore the basics and essentials of big data. I am Mubarak, your friendly and helpful guide in this journey. In this video, we'll cover what big data is, why it matters, how it works, and what it can do. But before we dive in, let me ask you a question. How much data do you think is created every day in this world? Take a moment to think about it and drop your comments below. Are you ready?
Currently, we have something in the region of 5 zettabytes of data in the world, right? So just one zettabyte is a sextillion bytes. This is a number with 21 zeros at the end. Put another way, a state-of-the-art home computer now has a terabyte of storage. It would be 1 billion of those. If you think this is a scary number, those 5 zettabytes will go to over 175 zettabytes by 2025. So if you put those 125 zettabytes on DVDs and stack them up, it would be a stack that reaches 222 times around the Earth. This for me hopefully gives you an illustration. So now look at how we do this every day and how this is adding up to these enormous volumes of data. So in a single day, we now generate 2.5 quintillion bytes of data. This is now a number with 12 zeros at the end. So where's all of this data coming from? Every single day, we send 300 billion emails. So this is a massive amount of data if you think not just the content of those emails, but attachments to these emails as well. Every single day, we also send 65 billion WhatsApp messages. This is all the information we share between us. And the weather company receives 26 billion requests for weather forecasts. So all of this data is generated continuously throughout the day and is growing those data volumes. YouTube is another example. Every day we watch 5 billion hours of YouTube. And every day we are uploading 500,000 new hours of video content to YouTube. Internet searches, every day we perform about 5 billion searches, and 3.5 billion of those will be done on Google. So again, this is giving this company huge information on what we're looking for. But again, each Google search is not giving companies like Google the content of what we're searching for, but also our location, data, and other information that is shared continuously. The other thing is we now have smartphones, and we have smartphones with cameras in them. So we keep snapping away. And every day we now take about 3 billion photographs, and many of them are then shared on Facebook and Instagram. We now share 300 million photos on Facebook every single day. So those 1.5 billion active users every day that use Facebook now share their photos, but they also share about 750 million status updates. Netflix, we're now watching 165 million hours of Netflix every single day. Twitter, 500 million tweets, 100 million photos shared on Instagram. Spotify, we love listening to music, and Spotify adds 20,000 new songs every single day. And in addition to all of this, we have all those smart devices that we're now surrounded by. We have phones that we carry around that continuously send information about our location, our speed, our altitude, even the weather conditions around us. We now have smart toasters, smart cars, smart washing machines, smart watches, and all of those devices are continuously generating data. Just think about some of the voice-activated speakers like Alexa and Google Home. They're collecting our voice information. All the face scans and fingerprint scans that we use to access our smartphones. All of this data is generating huge opportunities for businesses and huge challenges.
And that's just the tip of the iceberg. Data is growing exponentially every second, from every source in every form. So what is this data and why it is this so important? That's what we are going to find out in this video. Let's get started. So data is simply information that is collected, stored, processed for a specific purpose. For example, when you watch a video like this on YouTube, data is generated about your views, like, comment, and subscription. This data can be used by YouTube to understand your preference, recommend you more videos, and improve your experience. But data is not just numbers or text. It can also be images, videos, audios, geolocation, and others. And data is not just from YouTube. It can also come from social media, web, mobile, sensor, IoT, and others. In fact, data is everywhere, from your smartphone to your watch, from your car to your fridge, from your fitness tracker to your thermostat. Data is the new oil and valuable resources that can fuel innovation, growth, and decision making. But data is also big, very big. So big that it is beyond the capacity and capability of conventional data processing and visualization tool and methods. That's why big data comes in. That's where big data comes in. Big data that has high volume, velocity, and variety. These are the 3 B's of big data, and they are the key characteristics that define and differentiate big data from irregular data. Let's look at each of them in detail. Volume. Volume is the amount of data that is generated and stored. Big data is so huge that it can range from terabyte to petabyte to exabyte and beyond. To give you some perspective on how big data is, 1 terabyte is equivalent to 100 gigabyte, and 1 petabyte is equivalent to 100 terabytes, and 1 exabyte is equivalent to 100 terabytes. For example, Facebook generates over 4 petabytes of data per day, which is equivalent to 800 million DVD discs. Number 2, velocity. Velocity is the speed at which the data is created and processed. Big data is so fast that it is generated and consumed in real time or near real time. For example, Twitter handles over 500 million tweets per day, which is equivalent to 600 million tweets per second. Variety. Variety is the diversity of the data type and source. Big data is so diverse that it comes from structured, semi-structured, and unstructured format, and from internal and external sources. For example, Amazon sells millions of products across different categories and regions, and collect data from transaction, reviews, rating, and clicks, etc. So these are the 3 B's of big data, and they are the main challenge and opportunities that big data present. For how do we deal with these challenges and opportunity? How do we analyze and mine big data to discover meaningful information and insight? That's what we are going to learn next. To handle big data, we need combination of skills, tools, and technologies that can be stored, processed, and manage large-scale data efficiently and effectively. There are many tools and technologies available in the market, but we will focus two of the most popular and widely used ones, that is Hadoop and databases. Hadoop is a framework for distributed storage and processing of large-scale data. Hadoop is a framework for distributed storage and processing of large-scale data sets. Hadoop is like a library that stored and organized books across multiple shelves and allow multiple librarians to access and process them in parallel. Hadoop has two main components. One is HDFS, which is Hadoop Distributed File System, and MapReduce.
HDFS is like a bookshelf that divides books data into smaller pieces of blocks and distributes them across different shelves, just like a note, with the copies called replica for fault tolerance and load balancing. HDFS ensures that data is available and accessible even if some nodes fail or go offline. HDFS also allows data to be stored in different formats and schemas depending on the source and type of the data. MapReduce. MapReduce is a programming model that processes data in parallel across multiple nodes in a cluster. MapReduce is like a librarian that assigns tasks, jobs to other librarians worker and collects the result output. MapReduce has two main phases. MapReduce has two main phases: map and reduce. Map is a phase where data is read, filtered, and transformed into key value pair. Map is like librarian that scan book data and extract relevant information, that is key value pair, based on certain criteria, that is called function. And reduce function is the phase where data is aggregated, stored, and summarized by key. Reduce is like librarian that group data or books by category called keys and perform calculations function on them. Hadoop is one of the most popular and widely used framework for big data, and as it can handle large, complex, and dynamic data efficiently and effectively. Hadoop is also an open source and scalable, meaning that anyone can use it and modify it, and that it can grow or shrink according to the data need and resources. Hadoop is not the only framework for big data though. There are other frameworks such as Spark, Flink, Storm, and others that offer different features and advantages for different use cases and scenarios. If you want to learn more about Hadoop and other frameworks, you can check some of the resources that I have linked in the description below. Databases. These are the system for storing, retrieving, and managing data. Databases are like cabinets that store the organized file data in a drawer, tables, and folder record with levels just a field. There are two main types of databases. We have relational and non-relational databases. Relational databases are databases that store data in a table with predefined schema. Relational databases are databases that store data in a table with a predefined schema and relationship. So relational databases are like cabinets that have fixed and uniform drawer and folders and use key to link them together. Relational databases are good for structured and consistent data such as transaction, order, and customers. Relational database use SQL. SQL is structured query language to query and manipulate data. Examples of relational databases are MySQL, Oracle, SQL servers. Non-relational databases. These are databases that store data in flexible and scalable format without fixed schema or structure. Non-relational databases are like cabinets that have variable and diverse drawers and folders and use indexes to access them. Non-relational databases are good for unstructured data and dynamic data such as social media posts, web content, and IoT. Non-relational databases use NoSQL, that is, not only SQL, to query and manipulate data. Example is MongoDB, Cassandra, Redis, and others. Databases are one of the most essential and widely used tools for big data, as they can store, retrieve, and manage data efficiently. Databases are also diverse and adaptable, meaning that they can support different data types and resources, and that they can change and evolve according to the data need and requirement. Databases are not the only tool for big data though. There are other tools such as data warehouses, data lake, and data pipeline that offer different features and advantages for different use cases and scenarios. Also, if you want to learn more about databases and other big data tools, you can check out some of the resources that I have linked in the description below. So far, we have learned what big data is, why it matters, and how it works, and what tool and technology is used. But what can big data do actually? What are some of the real-world applications and examples of big data? In this section, we will explore two most common and relevant domains where big data applications utilize business intelligence and social media. Business intelligence. This is the use of data to support strategic and operational decision and action. Business intelligence is like a compass that guides businesses to navigate the market and competition and the customers. Business intelligence can help businesses optimize their processes, products, services, and strategies, and improve their performance, profitability, and customer satisfaction. Example: Walmart, the world's largest retailer, uses big data to optimize its supply chain, inventory, pricing, and customer service. Walmart collects and analyzes data from various sources such as transactions, loyalty card, online behavior, and social media. Walmart uses big data to forecast demand, manage inventory, adjust price, and personalize offer recommendation. Walmart also uses big data to monitor customer feedback, sentiment, and satisfaction, and improve customer service and retention. Walmart big data strategy has helped to save billions of dollars, increase sales and market share, and enhance customer loyalty and trust. Social media. This is the use of data to understand and influence user behavior and engagement. Social media is like a mirror that reflects the interests, opinion, and emotion of users and society. Social media can help users discover and ensure content and connect and communicate with others and express and share their views and feelings. Example: Instagram, one of the most popular social media platforms, uses big data to filter and rank posts, stories, and reels based on users' interests and interaction. Instagram collects and analyzes data from various sources such as likes, comments, follow, hashtag, and locations. Instagram then uses big data to create personalized feed, explore pages, and suggestions for each user based on their preference and behavior. Instagram also uses big data to measure and optimize user engagement and retention and growth, and provide insight and analytics to content creators and advertisers. Instagram's big data strategy has helped increase more relevance and enjoyable experience for its users and a more effective and profitable platform for its partners. These are just two of the many domains where big data is applied and utilized, and they show the impact and value of big data in different contexts and scenarios. Big data can also apply other domains such as healthcare, education, entertainment, sport, and provide various benefits and solutions for different problems. If you want to learn more about big data application and example of big data, you can check out some of the resources I have linked in the description below. Big data also is used in marketing. Marketing is a process of creating, delivering, and communicating value to customers and stakeholders. Marketing is like a bridge that connects businesses to customers and society. Marketing can help businesses attract, retain, and satisfy customers and increase their brand awareness, reputation, and revenue. Big data can help marketers focus customer behavior and product strategy. Big data can help marketers understand and predict customer needs, preferences, and behavior and tailor their product and services and messages accordingly. Big data can help marketers segment customers into different groups based on various criteria such as demographic, psychographic, behavior, and others, and personalize their campaign and offer for each segment. Big data can help marketers optimize their pricing, promotion, distribution, and product strategy, and test and evaluate their effectiveness and efficiency. Big data can help marketers measure and improve their return on investment and demonstrate their value and impact to their businesses and society. Example: Coca-Cola, one of the world's most iconic and successful brands, used big data to create personalized bottle with customers' name and increase sales by 2%. Coca-Cola used big data to analyze social media data and identify the most popular names among its target audience. Coca-Cola used big data to print and distribute personalized bottles with customers' names across different markets and regions. Coca-Cola then used big data to monitor and measure customers' response and engagement and the sales revenue impact of the campaign. Coca-Cola's big data campaign was a huge success, and it was boosted customer loyalty, satisfaction, and advocacy, and increased sales and market share. These are some of the type of ways that big data can help marketers achieve their goal and objective and create value for customers and stakeholders. Big data can also apply to other domains and markets such as content marketing, email marketing, digital marketing, and others, and provide various benefits and solutions for different problems and needs. So far we have learned what big data is, why it matters, how it works, what tools and technology is used, and what it can do. But big data is not all shine and rainbow. It also comes with some challenges and best practices that need to be addressed and followed. In this section, we'll discuss some of the common challenges and best practices of big data and how to overcome and implement them. Some of the common challenges are managing massive amount of data. Big data is huge and can overwhelm the storage and processing capacity of traditional systems. To handle this challenge, businesses need to use cloud-based solutions that can scale dynamically and efficiently. They also need to use big data software that can store and query data in distributed and parallel way. Integrating data from multiple sources. Big data is diverse and can come from various sources and formats such as web, social media, sensors. To handle this challenge, businesses need to use data integration software, ETL software, that is extract, transpose, and load software, and business intelligence software that can map, combine, and transform data from disparate sources into common structure and format. Ensuring data quality. Big data is messy and can be incomplete, inconsistent, inaccurate, or irrelevant. To handle this challenge, businesses need to use data quality software that cleans data cleaning software, data governance software that can validate, standardize, enrich, and monitor data quality and reliability. Keeping data secure. Big data is sensitive and can contain personal, confidential, and proprietary information that need to be protected from unauthorized access or misuse. To handle this challenge, businesses need to use data security software that encrypts, data encryption software, data privacy software that can encrypt analyze and audit data access and users. Selecting the right big data tool. Big data is complex and require a combination of skill, tool, and technologies that can handle different aspects and stage of big data project. To handle this challenge, businesses need to use big data platform, big data analytics software, big data consulting service that can provide end-to-end solution and guidance for big data initiative. Scaling system and cost efficiency. Big data scaling system and cost efficiency. Big data is dynamic and can change rapidly in volume, velocity, veracity, and value. To handle this challenge, businesses need to use big data cloud services, big data infrastructure software, big data optimization software that can provide flexible, scalable, and cost-effective solutions for big data need. Lack of skilled data professional. Big data is challenging and require a high level of expertise and experience in data science, data engineering, data analysis, data visualization. To handle this challenge, businesses need to use data science software, data engineering software, data analysis software, and visualization software that can simplify and automate the tasks and processes involved in big data project. They also need to invest in data education, training, and certification program that enhance the skill and knowledge of their data team. Organizational resistance. Big data is disruptive and can require a significant change in the culture, mindset, and strategy of organization. To handle this challenge, businesses need to use data management software that data collaboration software, data storytelling software that can foster data-driven culture, facilitate data sharing and communication, and demonstrate the value and impact of big data. These are some of the challenging best practices of big data that you should be aware of and prepare for. So we have reached the end of this video, and I hope you enjoyed and you learned something new. In this video, we cover what big data is, why it matters, how it works, what tools and technology it is used, what can it do, and what are the challenges and best practices it faces. Big data is fascinating and wonderful phenomenon that is transforming the world we live in and offer a massive opportunity and challenge for individual businesses and society. Big data require a combination of skills, tools, and technology to harness its potential and value, and it demands a critical and ethical mindset to ensure positive and beneficial impact. Big data is not just buzzword or hype, it is a reality and revolution that is here to grow. If you want to learn more about big data, you can check out some of the resources that I have linked in the description below. You can also subscribe to this channel and hit the bell icon to get notified of new video on big data and related topics. Thank you for watching this and supporting this channel, and I hope to see you again in the next video. Until then, stay curious and keep learning.